All right, good morning. I say good morning because it is actually morning, and it's 7 o'clock in the morning. I'll be in the building today. Sorry I didn't get this video out yesterday. We had a little bit of an issue with no room space, but anyway, you guys will be picking up a packet. It's going to look like this. Make notice of these two things that I've highlighted. First thing is that your homework assignment just says only the odds, and then practice 1 and 2 on pages 1 and 2 also just the odds. You can use the evens for a review. So, well, let's move into. This is the 2 pages that it was talking about as far as factoring goes. Greatest common factor, difference of 2 perfect squares, sum and difference of 2 cubes, as well as factor by grouping. Page 1, page 2. All right, let's get into the notes section so that way you guys have some notes for this. Now, once again, you can stop this video at any time to write things down as you wish. But simplifying rational expressions, the first thing we're doing is looking for factors to divide out. So we have to factor first. Methods of factoring, once again, we talk about greatest common factor, perfect square trinomial. Now I know that trinomials aren't always perfect squares, but I didn't really know what else to call it. Difference of 2 perfect squares, sum and difference of 2 cubes, and then factor by grouping. You can take any of these problems here if you'd like, and you can factor them out as such. Real quick, you guys have done this problem before, but let's take a real quick look at it. If I were to do this, then I'm looking at x plus 5, x plus 1. On the bottom, we have x plus 5, x minus 2. And we can see that this guy and this guy are the same thing, so they'll divide out. Divide give you 1 because they are the multiplicative identity, and you're left with just an answer of x plus 1, x minus 2. Okay? And you can go through the process with these. We've already done a couple of these in class the other day. I believe we did example 1 and example 5. And I think we also did example 3, but if not, example 3 is really simple. It's just greatest common factor. The greatest common factor for the top, well, this is just 5 times x, so there's really nothing you have to really worry about. The bottom here, they both have a 5x in common, so I take a 5x on the out, and then what's left over is 5x plus 2, and then our 5s will divide out, our x's will divide out. And now, here's that fun part where we talk about where I don't like the word cancel. Because so often, when we say, well, if this divides, or in essence, this cancels, what's left over? People are saying it cancels out, there's nothing left, so that means 0. It's not 0. They divide to 1 because of the fact that it gives you a 1. And then on the bottom is 5x plus 2. Okay? We will talk about leaving those in, or discussing what we factored out in regards to preservation of asymptotes, but we'll get into that a little later. Once again, we're just going to take time to make sure we understand the process. All right, next one, multiplying. When we're multiplying, the big thing we do when we multiply is we need to multiply fractions straight across. So half times 3/5 is 1 times 3, 2 times 5 gives you 3 over 10. When dividing, we must first invert the fraction and then multiply. We're not going to invert both fractions, just the one to the right, and then we multiply. So this is my fraction to the right, so it gets inverted or essentially flipped, or as you guys like to call, keep, switch, flip. So 1 times 5 is 5, 2 times 3 is 6. So that's how we're going to go through that. And like I said, we've done these problems before. You guys have examples of these, so I won't sully the time in here too much to give you more work time in class on how to execute these problems. If we want to do one real fast, well, if we do one real fast, why not? This guy is a sum of 2 cubes, so he's going to be x plus 1, and then he's going to be x squared minus x plus 1. The bottom is x minus 2, x plus 1. I'm going to multiply. This is now my numerator. This is now my denominator. This gives me x minus 2, x minus 2. And this guy here, not factorable. X squared minus x plus 1. The good news is, I have one of those right there. Oops, come on back. And then I have a minus 2 and a minus 2, and I have a plus 1 and a plus 1. So the only thing left in this problem is this guy right here. And we're done. Yay. Okay. Next section. When we add or subtract fractions, you must have a common denominator. If we take a half and we add it to 3 over 5, then we have to have a common denominator, which usually comes from, not usually, it does come from the least common multiple. So we need to remember that. Least common multiple between 2 and 5 is 10. So 5 times 2 is 10, 5 times 2 is 10. Then we have 5 times 1 and 3 times 2, so we end up with 5 over 10 plus 6 over 10 gives us 11 over 10. Same process here. Like I said, we did problems like this in class. I have the notes up front. You're welcome to take a look at them. If you were absent that day, take a picture of them. Do whatever you'd like with that. And last but not least, we have compound fractions. There's no secret for simplifying these. You just simply do multiple methods. So usually it's add or subtract and then invert and multiply. Sometimes it's multiply, then invert and multiply. Sometimes it's invert and multiply, then add or subtract, then invert and multiply. They just start putting pieces together. But it's just deal with the top. So split it in two. So deal with the top, then deal with the bottom. Then combine. Okay? You can do, obviously you could do the bottom first and then do the top. It doesn't really matter. Top, bottom, usually just the reason why I say that is because when we read left to right, top to bottom. So it just kind of already goes instinctively with what we want to do anyway. So, and that's pretty much it. We're going to work on these questions. When you're done with these questions, then we will have the homework assignment, which you can work on in class, as well as the evens for the pages 1 and 2. That's what we're going to do today in class. When we come back, we'll talk about the graphing, we'll talk about the asymptotes, we'll talk about all of that wonderful, awesome stuff that comes when we divide functions that have variables in the denominator. Hope this was helpful. If not, feel free to go back and watch it again. I will be in the building. You can't really come find me, but if I get some time away, I might slide in and see if everybody's doing okay. Have a wonderful day, and we'll see you soon.